guys, it's Link here, and today we'll be continuing boron. Super strong magnet. Big portable devices own their small size and big performance to strong permanent magnets made from an alloy of boron, iron, and the acetite element. Idea? Okay. The magnets can be found in headphones, cordless drills, and digital music players. And all of these devices emit force exert on the electricity flowing through the wires, which creates a magnet of the wire, causes mechanical motion. This motion can be used to move a diaphragm to make sound in headphones or to spin the shaft in a cordless drill. And music players with tiny high capacity hard drives, the motion moves an arm that reads digital music from the disk drive. Greater magnetic force of the boron-containing magnets compared to older types means less electricity is needed. This permits smaller portable devices and extends time between battery recharges. Glass that contains boron expands. It contains borons expands when less when heated. Reduces thermal stresses, and softens at higher temperatures, making it good for baking dishes, and laboratory glassware. Hydrogen fuel cell. Boron compounds may help reduce our use of fossil fuels such as oil, natural gas, and coal. Around the world, there's a concern about our dependency on these non-renewable fuels and the climate effects from using them. High-energy boron compounds can help ease these concerns by providing a clean alternative energy source for electricity in vehicles. One candidate compound is sodium borohydrate, NaBH4, which releases its hydrogen when combined with water and run over a catalyst made of the elements ruthenium and nickel. The hydrogen is then converted to electricity in a fuel cell. Then the byproducts are water and the harmless sodium borate, NaBO2, rather than pollutants thought to contribute to global warming. Test models of this borane-based fuel cell has run cars and are being adapted to smaller sizes to power laptop computers and portable electronics for extended durations. This approach has the benefit of being much lighter and longer lasting than metal-based batteries. And if you want to learn more about batteries, go check out a Blaze Alien. Boron is a special element, both in its origins and its amazing range of uses. It is created when cosmic rays shatter heavier elements. On Earth, it concentrates as compounds found in deserts where volcanoes and hot springs spill down from other rocks. These compounds help warm our homes, house electronic components, cook our food, and clean our laundry, to name it just a few uses. Chemists have recently been working on boron forms not found in nature. These new forms hold great promise for an even richer array of uses. Oh wow, that's exactly it. And wow. Anyways, that'll be it for today's video. Hope you guys enjoyed, and I'll see you again very, very soon. Later. Hello guys, it's Link here, and today we'll be reading Potassium by Greg Rosa. Now, without the way, let's get into it. Potassium by Greg Rosa. Introduction. What do you think of when you hear the word potassium? You may not know that potassium can be found in the earth and the oceans, or that the banana you had for lunch is loaded with it. However, did you know that potassium also exists as a metal that can be cut with a knife? Were you aware that it is an element found in many common salts? Have you heard that potassium metal reacts violently when combined with water? Potassium is an element that may surprise you. It takes many forms and is used for many surprising purposes. Many centuries ago, people began using plant ashes to make their lives easier by using them as a form of soap. A long time later, scientists discovered that plant ashes contain a substantial amount of the element potassium. Our understanding of potassium has come a long way. Today, potassium and potassium compounds are used for many purposes, some of which may surprise you. Consider the case of potassium superoxide. This compound is made by burning pure liquid potassium in a chamber filled with pure oxygen gas. The superoxide compound that results is used as a modern invention called a rebreather. Rebreathers are similar to scuba tanks, used by deep-sea divers. Instead of compressed oxygen, however, rebreathers can carry potassium superoxide. Rebreathers work by combining potassium superoxide with carbon dioxide, which comes from the lungs when the diver exhales. Chemical reaction takes place between the two compounds. They join to make two new substances, potassium carbonate and oxygen. The oxygen can be breathed safely. Rebreathers are smaller and lighter than traditional air tanks, and they allow divers to stay underwater longer. Underwater is isn't the only place where potassium superoxide comes in handy. The Russian Space Agency, for example, used potassium superoxide as a chemical oxygen generator for on-air spacecrafts and for spacesuits. Firefighters also use similar oxygen generating gear when battling intense blazes that involve smoke. Rebreathers help keep firefighters safe in hostile environments. Potassium superoxide is just one of the many valuable and often surprising uses of potassium. Chapter 1: The History of Potassium. Potassium is the seventh most abundant element on Earth. It is essentially for nearly all life. Potassium compounds are used for many reasons, from seasoning food to dating very old rocks. However, many people know very little about it. There are several reasons for this. Despite the fact that potassium is found in dozens of natural compounds and hundreds of industrial products, it rarely exists in its pure form as a metal. Pure potassium metal reacts quickly with oxygen and moisture in the air, which is a process called corrosion. Potassium metal must be stored in a liquid, such as mineral oil, to minimize the oxygen and the water exposure to the metal to prevent corrosion. Due to the fact that potassium metal reacts so quickly with other elements, it is not found naturally as a metal, but in compounds with other elements. Thus, scientists did not know that it was an element until 1807. Potash. Potassium is very important to living things. Plants need potassium to grow tall and strong. Their cells contain significant amounts of the element. A long time ago, people all over the world discovered that the ashes left after burning plants can be used to flavor foods. Although these ashes may contain many impurities, wood and plant ashes also contain a potassium salt called potassium carbonate. Native Americans and people in Asia also use wood ash to preserve meats. At some point, people decided to soak plant ashes in water and boil them in a pot. The result was a more pure form of potassium carbonate that could be used to make soap and glass. The English named this substance potash because it could be prepared by boiling ashes in a pot. Potash. Oh, it's potash, not potash. I've heard of that before. Another potassium compound. People began to notice that spreading potash in the 17th century. People began to notice that spreading potash in their gardens helped their plants grow. Another potassium compound that people commonly use was potassium hydrate, or conjugic potash. This is a similar substance to LiLi, sodium hydrate, NaOH, and is sometimes. Here, a young boy is slashing and burning fields, readying the soil for growing crops with the aid of potash, called potash lye. This was made by baking potash in a kiln to remove even more impurities along with carbon dioxide. The result was a fine white powder. Potash and other potassium salts, such as potassium chloride, also called sylvite, were eventually found in and around ancient seabeds. Potassium-rich minerals are also discovered in Earth's crust in 1797. A German scientist named Martin Leoproff found potash in a volcanic rock in Italy. Scientists eventually found potassium in other rocks, particularly in feldspar, a component of granite. As more potassium compounds were discovered, potash became a catch-all term for the most potassium compounds, which sometimes resulted in confusion. For many years, scientists thought that potash was an elemental substance, meaning that it cannot be broken down. Sorry for that. Meaning that it cannot be broken down any further. It was also confused with a similar substance commonly called soda ash, or sodium carbonate. However, one scientist questioned Free Andersons and worked to prove them wrong. Sir Humphrey Davy was first isolated potassium from cosmic potash in 1807. Davy used a process called electrolysis, which involves passing an electric current through a sample, in this case through molten cosmic potash. It was the first metal to be isolated in this manner. Others quickly followed. Shown here is a portrait of Martin. Martin was the most important chemist of his time in Germany. Davy immediately named the substance potassium, a term derived from the word potash. Potassium and potassium compounds have been used for numerous applications. Today, potassium chloride is one of the most common industrial chemicals. About 95% of the potassium refined today is used in the manufacture of fertilizers. Aside from fertilizer, soap, and glass, potassium compounds have also been used to manufacture explosives, gunpowder, medicines, and many other products. The methods for obtaining and refining potassium have been also improved over the years. Sir Humphrey Davy, 1778 to 1829, was an English chemist who discovered potassium. But he is known for other important chemistry milestones. Thanks to discoveries of Italian scientist Alessandro Volta, has developed the first working battery. Davy began experimenting with the electrolysis of salts using batteries. Davy was convinced that some substances that were considered elemental, such as potash, could be broken down into smaller parts. After several trials, Davy successfully isolated potassium by running an electrical current through an iron plate and held molten potash. Davy was elected to see small globs of a silver metal forming from the contact potash. He named the metal globs potassium. Over the next few years, Davy went to isolate another metals using similar techniques, including sodium, calcium, strontium, barium, and magnesium. Davy was knighted for his discovery in 1812. French ruler Napoleon Bonaparte awarded him a medal in 1813. This is a 1931 version of electrolysis equipment Sir Humphrey Davy used to isolate potassium. Modern electrolysis equipment hasn't changed much since Davy's day. Remove the V on Davies and then you get days. Periodic table. Periodic table is a useful chart of the elements. The table also allows scientists to conveniently see the relationships between elements. It can also be used to predict the structure and behavior of compounds combining the elements. Most periodic tables list basic attributes for each element. In the years leading up to 1869, several chemists from around the world were close to organizing the known elements into a unifying table. Scientists began to assemble elements into groups based on similarities they noticed between them. In 1869, a Russian chemist named Dmitry Mendeleev developed an early form of the periodic table that we are familiar with today. Mendeleev was not the first to divulge such a table, but he was the first publicist for his system of elements. So he's usually given the most credit. Mendeleev assembled the elements based on their atomic weights. Once he did this, he realized that certain characteristics occurred in regular intervals or periods. Mendeleev and other chemists who followed his lead left gaps in the table where he predicted new elements would appear once they were discovered. The predictions that Mendeleev and others made were sometimes correct. Once convinced skeptics of the value of his organizational tool over the years, other scientists refined and added to the periodic table. However, it still follows Mendeleev's original concept. And that is for today's video. Hope you guys enjoyed, and I'll see you again very, very soon. Later.